Welcome to Go. Loops are a very powerful programming construct that allows us to do things repeatedly. In Go, there is only one keyword, which is the for keyword. That is what we use to do loops in Go. All right. Imagine you are in an interview and the interviewer asks you, what is the difference between this loop and this one? Well, just by looking at the code, based on how it is constructed, for sure we know this one there is range here and this one there is no range here. If you give this answer, you probably have failed the interview, because anyone asking this kind of simple question, they have a different motive, which is really about data. Programming is all about moving data here and there, and in Go, we can do so much just by understanding how our data moves from one location to the other, and that is where memory comes in. Somehow, when you program in Go, you are forced to think a little bit low level, and it is very sweet. It is also quite interesting to think at that level of computing. All right, so let's see. Another way to do this loop is also this. So let's have this third one here again. You see, here we have the for, and then there is supposed to be index here, which I have omitted deliberately. And this one, only the index, and there is no value, right? But what is the difference between this, and this? Well, let's run the code so I can explain to you. Now that I executed the code, we can bring it up here a little bit and let's look at the code. First of all, I have this function here, which is demo users. It's a very simple function that basically creates just a slice of users and return them with random data. So it is nothing complicated. All right, now let's go back to main. Here in main, the first thing we did was to loop using the range loop. But in this loop, we have the index and the value. And look at the data. From user with ID 0 to 9, so we have 10 users here. And then this is the memory address of each user. Now, this is very important. This is the most important part of the video. So please pay attention at this point. If you look at the memory address, the data is actually not very far from each other. This is the first user, the second user, and this is the memory address of where the data is in memory. Great. Now we do another loop, which is the second one here. Very similar to this, but this time around we are only using the index. We are not interested in the value. So what happens if then we loop again and then we printed out this? But notice what is happening here now. Did you notice that the memory address of user with ID 0 is different from this? The same user, the same data, but something happened. The memory address has changed. That means something has copied. A copy operation just happened. Now, before I explain what is going on, let's look at the third one, which is this one. This is the classic for loop that we know, which doesn't use range at all, but we are using the index here. And at the same time, we also use the index in the second one. But if you notice, the memory address for the data here and here is the same. That means, what this is telling us is this. Anytime you use the range loop with value like this, this value you have is a copy. This U is copied. Very important. U is copied. That means if you have 10,000 users here, you are going to have 10,000 copies to different memory addresses. That is the cost of using this for with range, and then you are interested in the value. So it is copied. The second thing I also want to show you is, let's say I comment everything out. This time around, I want to comment everything out. I have another function here. Which is, let's collapse this, which I call performance test. Before I run this function, I want to make this clear. This, even though I name it performance test, it is not testing the performance per se. I am just trying to show that there is a cost to this approach of looping. Now, let's use that. And then let's pass it the users, and then I'm going to run the code again. And let's look at the analysis. So it says testing range loop with copying. So this is the first one, this one that we know. We're using this now with copying over. We have 10 users here, and then we loop. We did a 100 iterations. I can show you the function quickly after this. And then this is the time it took. Then we did the one no copying. This is the second one with range, but no value. So we are using the index here. And look at how long it took. Then the analysis came back that the range loop, this one, that is 26.33x slower due to copying. Now, if you keep running it over and over and over again and over again, you're going to always have different numbers here. It's something that you need to keep in mind. Performance can be very tricky. If you want to do performance tests, it has to be with real data, real customer, different environment, the real system that you are using to run your product, and not this kind of performance test that I'm doing. This one, I'm only showing you that there is a cost to this loop, that even though you can do, for example, let me comment them out again. Even though sometimes you can just do this very easy, there is a cost to it, and that cost can be significant, especially, for example, look at our data structure here. I have a metadata here that is big, that is about, this is 10K here. And imagine you have a lot of other data structure that are that huge. Each time you loop over it, you are copying each of that data, and that can fill up your memory quickly. So if your program is filling up memory in your cluster quickly, then you need to start looking at some of these little optimizations that you can do here and there. But until then, this is what most people use. There is no need to change it. But I just want to make this video to show you that there is a lot of little things here and there, little optimization opportunities here and there in Go that you can take advantage of. And that's it for the video. So which of them should you use? Well, for me, this is very convenient, and most times I go with this. What I do basically is, what we do here, instead of me, because this U is very convenient to use. So what I do instead, I come here and then I do U, and then I continue to use the U here instead of passing around the index, So this is what I do in most of my code. And this is, for me, this is better. Until you need to do this, I think this is better. Especially, this is also important, especially if you need to modify the data, then this becomes better. Like, for example, if you need to set, let's say, counter now to 10 or whatever, then this becomes very important. All right, thank you so much for watching the video. For the performance test code, it's very simple. Let me just show it to you before I end the video. You see, we are just looping. I'm do a little bit of cleanup with the garbage collection, and then put a timer just to stabilize things a little bit. There is nothing fantastic about it, and that's it for the function. All right. See you in my next video, where we keep digging into some of what I call like the Go secret, some sweet part of Go that people usually don't think about. That for me, sometimes I just sit down and just try to understand how things are working under the hood. And that's it. Bye for now.